And welcome to the Daily Space Weather Show. We've got a little uptick in solar activity here. We've got a higher likelihood of solar flares. We've got another coronal mass ejection headed toward Earth. Some very dense plasma. And a bunch of plasma filaments. It's exciting stuff here at the Smash News Network, least busted name in news, and thanks for tuning in. Congratulations on realizing the channel exists. And so, I figured I would show that because, it's, there's a green screen and, whoa, all right. So that's what's going on. So, anyway, check out the imagery. We've got some fresh imagery indeed today. These are 24-hour videos from Solar Dynamics Observatory. So that is a large sunspot. Somewhat magnetically complex. This is a much smaller sunspot with a lot more umbre and much more magnetically complex. So another prime example of how a large sunspot does not necessarily indicate an exciting sunspot. We've also got a cool plasma filament up here I figured I would throw in. And it is definitely still hanging out up there. I'm looking at the feed right now from the GOES 18 SUVI. Little crown prominence up there. Here's the equatorial view. And the most active sunspot has actually been in that northwestern limb, I think. We have a little bit of flaring activity in the southwestern limb also. You may see a CME popping off in the southwest, kind of directly below the Earth scale there, south of the solar equator, right there. Another CME, like I said, is headed Earth's way. So here's our most active sunspot, or T-mass. It's the T-mass for the 17th of March, 2024. Here's another awesome filament still being suspended by the massive magnetic fields of sunspot 3599, still making an impact despite being well out of view. So while its flare-making capabilities have expired, at least from Earth's perspective, still a bunch of plasma trailing behind that massive sunspot 3599. There's our full disk view, and let's move on to cover a bunch of stats. So first, the colorized magnetogram. That's the first order of business. There's SDO, colorized magnetogram, and that's the current situation. And speaking of situations, Iceland's got a situation, and we'll cover it here right after you press the like button. Yeah, press like, whether you're new or a veteran viewer of the channel. Press like, press subscribe, visit the links, hit us up on social media, press the share button, press all the things, and write things in the comments, and tell your friends and foes about the channel. And if what we say makes you mad, then that's all the more reason to get those fingers limbered up for the comments section. So check it out. Like I said, there's a bit of a situation going on. How you like them apples? That's a situation, right? So a legit hellscape going on right now. That is a live feed from what is it? Live from Iceland.is, one of their many webcams. That's the one that I selected. But just a series of lava fountains happening there, and you may even see a new caldera forming right there. There's a new cinder cone that's forming right there as the Earth geoengineers itself. So, always exciting to watch that happening as some new real estate forming there at Iceland, and unfortunately, damaging some old real estate, let's just say. So here's our new fault map, and that purple zone is not a place to be, as there are sinkholes, fault movements, tephra, gas pollution, eruptive fissures without warning, and lava flow. So if you'd like to become part of the Earth's mantle, that's a great place to do it. Visit that nice purple zone right there, and you might get swallowed up by the Earth and become part of the lithosphere as lava. Don't be the bridge between lava and magma. You know, when magma is above the surface, it turns into lava, kind of like the way a meteorite don't be the bridge between a meteor and a meteorite, and don't be the bridge between magma and lava. So you'll find huge write-ups about Iceland. Of course, they're very detailed there. They are, after all, sort of, they've been dealing with volcanoes a long time. I'll just say that. You can find lots of information there. Volcanodiscovery.com is what we're showing here. The town of Grindavik, once again in the crosshairs, as the Reykjanes Peninsula goes into another quite exciting eruptive state. Ibu's also erupting, also Dacono. Fernandina in the Galapagos Islands continues to send lava toward the ocean. Popocatépetl, San Guido, Fuego, Nevado de Ruiz, Revenador, and Sabancaya all erupting. And we see a number of earthquakes that may be foreshocks in the past 24 hours. So if you're in an earthquake-prone zone, note that there is a 7-magnitude earthquake drought currently happening. Look how long it's been since January 22nd or 21st, something like that, is the last time we had a 7-magnitude quake, and it was barely a 7-magnitude quake. So big-time 7-magnitude earthquake drought, and we see a lot of activity around the Pacific Rim, as you can see here. So we did have a 5.6 at Nicaragua early this morning at 0 dark 44. 5.6 at Nicaragua, just off the coast. Here is a Somalian earthquake. That's a pretty rare spot to see one, a 5.2 there at the is that the Arab plate? I'm not sure, but between the Arab and African plate right there. Right between at the Gulf of, what is that? The Gulf of Suez? I don't know. It's something. It's a thing. Somalia, northern Somalia had a 5.2, a fairly rare spot. Papua New Guinea had a 5.4. Remember, folks, any earthquake can be a foreshock. We don't claim to forecast earthquakes on the channel. That's just ridiculous. And if you're going to forecast earthquakes, I think the best way to do it is just with statistical analysis. I've yet to see any predictive value in any of the claimed correlations between the ionosphere and so forth. I don't see predictive value. I've looked into it and looked into it and looked into it, and the other claims that are made by certain channels about earthquake forecasting, not seeing it. Anyway, the radio flux has gone up. So back to space weather, the 10.7 centimeter radio flux now at 151, I believe it is. So that's only showing 144. That'll be updated in a few hours here. 151 is the new radio flux number. There's a space weather enthusiast dashboard. We have a very slow solar wind and very weak geospace at the moment. So the current state of geomagnetism is very weak. We're going to do a cosmic ray report today. Here are the past 4 hours of Earth's magnetic moment from space, and you're going to see very weak pressure around planet Earth. So we've got a slow solar wind, and it is also rather diffuse. So, and we've got a KP0. So, look what's going on. Oh my God, my chest is full of space. Dear God, my chest is full of space, folks. What will I do? Well, what I'll do is show the ground magnetic perturbations map. So there it is. That's also 4 hours. And you're pretty unlikely to see the aurora right now, even if you're in places where it's pretty common. You're gonna have to be pretty close to the magnetic poles to be seeing aurora at the moment. Very, very weak activity, including a solar wind showing below 300 at some of our sensors. So KP index, again, it's at 0. KP0 is the current situation. The weakest geomagnetism gets. Stay there. There we go. KP. Now then, how dare you? KP0. Yeah. So let's do a cosmic ray report. We're going to go all around the world to cosmic ray monitors. First, DOMB Antarctica, and it is up a few percent here. 1, 2, 3, 4. 4% increase at DOMB Antarctica over the past 30 days. DOMC Antarctica, a similar increase. About a 3.8% increase at DOMC Antarctica. At Oulu, Finland, going way up north to Finland, we've got another increase there. 1, 2, 3, 4. 4.6% increase at Oulu. Let's go way down south to the land of Greece. No, Mexico first. Mexico City showing about a 3% uptick in cosmic ray activity. Next we'll go up to Greece. There's Greece, and at least over the data we see there, it's let's see, that's about a 0.8% increase in cosmic ray flux there from the Athens neutron monitor. And then we'll go back up to Apatity and Barentsburg. So their Apatity is up Apatity is up over 4% over the past 30 days, and Barentsburg is also up a little bit less there, more like 1%. So, however, you can expect cosmic ray flux to decrease for the coming about 14 months because it does lag solar activity after all. So the solar plasma helps to mitigate cosmic ray flux. And yeah, that's just the way it works. It has to do with magnetic fields and so forth. And yeah, expect cosmic ray flux to continue to drop here. And of course, you would expect to see a little uptick over the past week or two as solar activity has been very mild. So speaking of which, check it out. We did have a CME impact here, like a sputtering, wavy filament move past ACE, as we saw the solar wind density reach all the way up to 138 protons per cubic centimeter. So 138 was the solar wind density there for a moment, but not at a very fast speed, so still only 381 kilometers a second. And it was sputtering, as you can see. It was switching back and forth between 1 proton per cubic centimeter and over 100. So that's an interesting sputtering, like probably a wavy plasma filament there, made its way past the ACE. Current conditions much less interesting, very, very slow, below 300 kilometers a second for the solar wind velocity. Solar wind density back down to 1 proton per cubic centimeter. At the Discover, a completely different scenario happened. Nothing even slightly similar to that. We do see 2 solar wind regimes there, so perhaps a different wavy filament there at Discover. You see the variation here between 6.5 protons per cubic centimeter and about 2.5. Also the velocity changing there between about 440 and about 480 kilometers per second. Now we've settled in to a higher speed regime. 477 is the current situation for solar wind velocity. Solar wind density 6.7 protons per cubic centimeter. GOES magnetometers here are quite smooth. We're seeing lower highs and lower lows. I mean lower highs and higher lows. That's it. Yeah, the whole graph has moved up in the past 2 days. See, there's a 7-day graph and a tighter range and at a higher level of magnetism. So the GOES 16 and the GOES 18, they have geosynchronous orbits near the equator. And Earth should be in a South Pole magnetic sector by now, right? And indeed Earth is South Pole magnetic sector, as we cited in yesterday's video. Welcome to the South Pole magnetic sector, just in time for spring in the northern hemisphere, or autumn in the southern. Here's our line of sight field plot. And yeah, that's a lot of information in a very minimal amount of time. If you don't know what it means, leave a comment, and our viewers will answer your questions if we don't ourselves, as we empower our viewers to be able to forecast both space and Earth weather. Next, coronal holes. There's our line of sight coronal hole plot, and we're going to move on to show whatever the Smash News Network least busted name in news wants to show. Now that I got that out of my system, there are coronal holes from SDO 211 angstroms, and we've got a very well-defined one of undoubtedly South Pole magnetism right in there. Let's check it out. Here's the last image. There it is, South Pole magnetism. Indeed it is. So that's another 24-hour SDO video. And you can see that CME, another one, headed toward Earth. You can expect it to arrive sometime later in the day on the 20th, by the way. We'll get to more about that. But first, some more stats. So the sunspot number is next. Sunspot number here just about to go back up over the average. So what does that do? That pulls the average higher, because We aren't at the peak of the sunspot cycle yet. You see, solar sunspot maximum cannot be declared until after it has already passed. And we aren't at solar sunspot maximum. We can expect that sometime around October of 2024. So that blue, what is the function of that graph right there in terms of what it does to the blue line? Well, at the moment, it's moving that blue line up because more of that graph is above the blue line than below the blue line. So it's going to, in effect, move that blue line up, and now it's going to continue to move the blue line up because one of those if not both of them, at least one of those sunspots is not yet counted. In fact, both of those new sunspots are not yet counted. So the setting sunspots are going to be offset and then some by the new sunspots in the east. We'll see another increase in sunspot number, not just from growth, but from those rising groups. Anyway, here come some sunspots from SDO. Again, those two new groups that just rose in the east, they aren't named yet. And especially the one in the southern hemisphere, that's going to have probably maybe 50 sunspots attributed to it there, as it's got a number of umbrae. We'll show you some close-up imagery of it later in the video. We also do have some growth there in the center of the solar disk. So there are several magnetically complex sunspots right now. So the likelihood of solar flares has gone up precipitously in the past 24 hours. So next we'll show the energetic particles and flares, proton flux here returning to baseline levels, and polar flights are becoming less and less radioactive. Yeah, radioactive. So we've seen an increase in the X-ray flux here, and a number of sunspots are now capable of producing large solar flares. The most likely one is indeed in the southeast. It has been the largest flare producer over the past 24 hours. And let's take a look at the SDO 94 angstroms. How sweet it is. And I'd say it's the right color for the day, wouldn't you? Did you have corned beef and cabbage? Did you see our Instagram page? No? Instagram.com/Smashomash. So here's our equatorial zoom, and I believe the most active sunspot is that northwestern group. So up there in your upper right, I think that's produced the most flaring, although the most X-rays overall are certainly from those two new sunspots in the east. So the biggest peaks were from that northwest region, but there are a lot of X-rays coming from the east. And here is our T-mass. I believe it's our most active sunspot there, at least producing the most flares, or the largest flares. And let's don't go to that yet, but that's kind of important. Oh, we'll get to it. Don't you worry. CMEs are coming. 3 of them are on the way already. So here's our star chart. We like to know what's going on overhead. This is what's going on over my head. As the sun is setting, Saturn just set. We've also got Mercury, Jupiter, and the moon all up there in the early evening sky. So maybe you'll catch that if you're viewing. Next, the solar system forecast. And spring is almost here. Here's your 1-week forecast for celestial bodies. That's where things will be in 1 week. Notice how Jupiter and Saturn are getting farther and farther away from each other, folks. Yeah, farther and farther away from each other. I'll just leave it at that. The barycenter. The barycenter. It's not in charge of solar activity. Sorry. That's astrology, not astronomy. Anyway, we're only 2 days and 5 hours from spring, folks. You've almost survived another winter so far. So, yeah. Spring kicks in at Tuesday, March 19th at 11:06 and 28 seconds p.m. Eastern Time. That is the moment when the sun's equator crosses right across the Earth's equator, making all the shadows parallel with longitudinal lines. And let's get to our astronomy photo of the day. It's some merging galaxies there. And, did you know that when galaxies collide with each other, they primarily just pass through each other because they're mostly empty space? Most of the interactions are not anything resembling collisions. They're just minor gravitational alterations of each other's courses. Of course, the cores have a tendency to combine, probably. But, yeah, and that's what's kind of going on there. Those galaxies are largely passing through each other. And of course, you can see some possible activity being kicked up. Lots of blue stars there, both in the trailing jet, or perhaps that's ejecta from the collision. Who really knows? You'd have to look at the redshift of everything to really see how everything is moving in relation to each other and so forth. But that's a pretty good galactic merger, wouldn't you say? It's NGC 7715. It's actually two galaxies, NGC 7715 and NGC 7714, which will eventually likely form one elliptical galaxy, one roughly spherically shaped galaxy. That's what we often think that we're seeing as a result of galactic mergers. Anyway, let's move on to CMEs. And like I said, there's another one headed Earth's way. So right early in the day today, seeing it come out of the coronagraph around 5 o'clock Universal Time this morning. Significant CME there with a partial halo, because part of that ejecta is headed right toward Earth. Now, the densest portion of it will miss Earth to the southeast, which would be to your lower left, but a large portion of the ejecta will arrive sometime around midday or later on the 20th. So CME's arriving on the 19th and 20th. Space weather, it's kicking up again, which it'll do again and again and again and again and again until October of 2024. So there's our LASCO C2 and C3. And let me bring that latest Earth-directed CME back. Here it is this morning, and there you can see a partial halo there. Almost a full halo from that one. Again, most of the ejecta will miss to the southeast, or the densest plasma at least will, but a large portion of that is headed directly toward Earth, especially when you see where it came from. So a lot of plasma is headed our way now. No less than 2, probably 3 CMEs on their way to Earth. We'll also show stereo A, and we're just showing this diagram to show you where it's located. This awesome diagram of where is stereo A is showing you the Parker Solar Probe, the Solar Orbiter, Bepi-Colombo, stereo B in blue, and stereo A in red. So here are the stereo A coronagraphs, and we've paused them at 5:23 this morning just to show you that CME. It looks like a halo from stereo A's perspective as well. And you can see that dense plasma. The densest portion will miss Earth to the southeast, but a large portion will strike Earth, possibly causing significant geomagnetic storms. Fingers crossed for that. And let's move on to our custom coronagraphs, which are splentacular. Those are 24-hour synced up videos. And you can see that densest filament. You can actually follow it right out of the corona there. It's just awesome. You don't always get that good of a view, but this time the view is pretty splendid. Very nice. And of course, when you have a major CME that close to the center of the solar disk, folks, it's very likely to have earthly directed components, even if it doesn't look like it on the coronagraph. So this is why we've added this difference imagery. It helps to show some more contrast for solar filaments. That's 193 angstrom 60-minute running difference, along with 304 angstroms and the LASCO C2 coronagraph, part of the SOHO spacecraft. So that's just SDO now, 304 plus 193 angstroms running difference. You'll see those plasma motions in great detail. And before we go to filaments, let's take a look at some filaments here in close-up detail. There's that crown prominence at the northern polar region. Here's this new sunspot that hasn't got a name yet. It's large, it's not that magnetically complex. This one is a series of small umbrae and is very magnetically complex. And of course, this massive series of filaments that are trailing sunspot 3599, as well as a great close-up of that CME's origin. You'll also see a massive series of Hyder flares. Those are the secondary features there. Plasma lighting up as it descends into the drastically deep gravity well known as the Sun. Once again, here's our T-mass for the last 24 hours, the most active sunspot. It's some sunspot that has a number, and I don't memorize things like that. Numbers are largely arbitrary. So there's a full disk view, and I think that's probably the best view of that latest Earth-directed coronal mass ejection. Again, expect that to arrive sometime midday or later on March 20th, Wednesday. So Wednesday into Thursday night, we may see some significant geomagnetic storms. This is the most earthly directed event we've had in quite some time, but there are 2 more coming the day before as well. So it's an uptick in space weather. And the sun, it always has a tendency to, well, first of all, it keeps some tricks up its sleeve, but it's not being a plasma miser anymore. So anyway, let's get to filaments next. There are filaments from Cerro Tololo. And we still have a massive number right pointed directly at Earth, folks. So, I mean, that one right there is definitely worthy of a name. Name that one after your friends or foes on our Twitter page. Let's show you how. Just copy the image and then head to x.com/smashomash. Really? There it is. And just put up a post. You know, let us know which filament you're talking about, and just put the hashtag. Name that filament after living humans. Right? The answer is yes. Yes. x.com/smashomash. So here are the past couple of hours, and it's, yeah, there are some flares happening here. The likelihood of large solar flares is very high. We've got multiple regions that are capable of producing them, especially in that southeastern quadrant. So, which would be your screen lower left right there. Those are that's the most likely place for a large flare right now. That new yet unnamed sunspot. Let's get the bonus features. Charging hazards are first. We ain't got none. It's smooth sailing. No high energy electrons building up in spacecraft and no low energy electrons building up on spacecraft. There is our GOES electron flux, which is the electron flux measured at the F layer of the ionosphere using radiography from the geosynchronous orbits of the GOES 16 and GOES 18. And there's the 1-year graph to contextualize it. It's in a middle operating range. Electron flux now back to normal following a multi-month electron drought. And next is our relativistic electron forecast. So NOAA's expecting a dip in the next 2 days, and I would tend to agree, as there are 2 or 3 CMEs. You know what the numbers 2 and 3 are, right? There are 2 to 3 CMEs on their way to Earth. So that's what's going on. Next, we'll show the layer where it's measured and how it is vibrating. Now, of course, you'll see the highest vibration around noontime. That's because of sunlight. That makes the ionosphere get puffy and excited. Of course, on the midnight side of the planet, it's a little bit unexcited, where you only really have it's just like one layer. It's not really like multiple F layers and things. But the higher frequency you get, the more additional double layers you get forming there and so on. We are seeing some high frequency anomalies showing up, which is a thing much more common to extremely weak geomagnetic activity. So those those high frequency anomalies there are not uncommon at all when we have a KP0. Here's that's anomaly in megahertz from a 30-day median, and as you know, you'll see a lot of blue on there because major high frequency anomalies. It's vibrating at a very high frequency. So now keep in mind, this is space. It is above the D layer of the ionosphere. So this is still space weather. If you get below the D layer of the ionosphere, now you're in Earth weather. as that is mostly neutral material. Next, total electron content and maximum usable radio frequency. If you don't know what those mean, well, leave a comment and somebody will fill you in, we hope. Total electron content and maximum usable frequency. We'll close out with a little closer look at especially these new sunspots. So let's briefly take a tour of these. That's magnetically complex. That's beta gamma class. That one there is beta gamma class. And that one there is beta class. That one's probably beta class. Now these. That's beta gamma delta class. And that is, yowzers, what is that? I'm not sure. Let's check. Let's get a little closer. All right, so that one is, let's see. Well, it's certainly beta gamma class. I suspect it's just beta gamma class. A little too early to say for sure it's beta gamma delta. I think it might actually be beta gamma delta, but I don't have a good enough view of that yet. It's a little deceptive when it's that close to the limb, so let's just hold off and say it's at least beta gamma class. And let's get to meteorology. So the first thing we're looking at today in meteorology is the highest pressure in the world. Do you feel like you're under pressure? Well, you're not under that much pressure, I pretty much guarantee it, as unless you're wintering in Antarctica, that is more pressure than you are under. 1,076 hectopascals is very high pressure, and also the world's lowest mean sea level pressure is right there as well. Only 948 hectopascals there, so high and low right next to each other. And keep in mind, folks, imagine if you were submerging your hand in a kiddie pool, right? Let's say this is your hand. You're pushing down, right? Here's your hand. That's a good hand, right? Yeah, there you go. You're pushing down on this area. That's effectively what a high pressure zone is. What does that do? It makes the area around it want to reach equilibrium by So when you press down on some water, you make higher pressure right under your hand, and the area around it has to have lower pressure to try to reach static equilibrium. So that's a thing that happens with an anticyclone, and that is the world's strongest anticyclone over the highest and driest continent, the world's largest desert, the continent of Antarctica. A very weird place, and it is so on my bucket list since the 1980s. Anyway, surface winds and jet streams are next. So let's do it. There are the surface winds of the east. There are the jet streams. Jet streams of the central world. Surface winds. Surface winds of the west. And the jet streams. Satellite imagery's next. How sweet it is. We like doing these videos when it's light out, as we show visible satellite then. So good. Visible satellite for the win. Look at how good NASA is at projecting the flat Earth onto an oblate spheroid template and making people think the Earth is shaped like anything besides a croissant. Everybody knows Earth is croissant-shaped, right? Viewers, you are aware that Earth is croissant-shaped. You're still believing NASA's lies? Come on, folks. Don't you know about Operation Paperclip? That proves Earth is croissant-shaped. Didn't you know this? Good God. Anyway, now we're looking at the ozone layer, as this shows us what's going on in the stratosphere. And check it out. All the ozone is over the northern hemisphere. So look at this. Ozone pretty high up here, 495, 510 DU, which is some kind of units. I don't know what kind of units, but some kind of units. Down here, only 234 DU. It's like the ultraviolet light is, I don't know, whatever. More ozone over the northern hemisphere that's what's going on in the stratosphere, the site of the ozone layer. Next to our weather.gov map, and we've got a bunch of cold freeze warnings and so forth on the Gulf states, also some severe weather around the Gulf of Mexico. We scrolled down to show you the key. If your location is lit on the map, just head to weather.gov, the National Weather Service homepage, and click your location to get your personal weather alerts. Here comes some forecasts. The GFS 72-hour pressure and precipitation is first. Next is our accumulated positive snow depth. So this is the end of winter, folks. This is the final forecast for your winter 2023 to 24. That shall be the final snow of winter. Since that goes into spring, it's actually in some ways the first snows of spring as well. So, however you want to look at it, it's you may be spooked of snow or a lack of snow or moderate amount of snow. I don't know. Let us know in the comments what you're spooked of, and we'll try not to laugh and laugh. Next is our temperature anomaly forecast in degrees Celsius, and some very cold weather, like 12 degrees Celsius below normal coming to Mexico, the Gulf states. And anyway, there's the map. I'm not going to try to explain it. A picture says 1,000 words, so I will say fewer. And last but not least, the jet stream, the real culprit for your weather. And you can see some cold Canadian air there pushing in past the Great Lakes into the Mid-Atlantic states. Thanks a lot for the cold air, Canada. You hoofty hosers, you. And then you can see a second jet stream there forming over Texas and sort of intensifying and so forth. And again, that's just what's going on. So some heavy lightning here around the Gulf for the past about 10 hours. And we do have some terrestrial strikes here off the coast of Panama City and the Apalachicola National Forest. That is a swamp of swamps. An estuarial swamp, meaning it's salt water. So anyway, that's where the lightning is striking at the moment, according to blitzortung.com's lightningmaps.org. Or is it blitzortung.org? I forget. It's blitzortung.org and lightningmaps.org. It's a valid nonprofit organization trying to get less people struck by lightning. That's a noble cause, I'd say. Lightning strikes, not particularly survivable. Anyway, we've got some lake effects precipitation happening here as cold Canadian air blows in and causes areas to reach dew point. So, at a given humidity, folks, if you lower the temperature enough, you'll get precipitation, which is fog, rain, sleet, or snow. That's how dew point works. Because temperature and pressure and humidity, they're all related. So here's our satellite imagery, and there is our water vapor map. Some moisture here making its way into the southeastern states, and some huge pressure gradients forming there around places like Houston. You see those areas right there where there's dry and moist air right next to each other? That represents massive pressure gradients, which equates to atmospheric waterfalls. Anyway, because folks, moist air can't suspend, air that's more massive can't be suspended by air that's less massive. So it's forcing it to change altitude, and that does all kinds of funky things up there. And here's your recap. U.S. Doppler radar. There is satellite imagery once again. And there is the water vapor map. When your Doppler is unclear, try that. If you understand the physics, that will tell you what's really going on. In other words, if you're suddenly seeing rain appearing on your Doppler, you're like, what's making the rain appear? Well, it's probably cold air infusing in, or it's a pressure gradient. So anyway, water vapor map will help show you where those features are. And again, we empower our viewers to forecast both space weather and Earth weather. So it's like a bodily function for this channel at this point. So thanks for tuning in. And until next time, may that solar wind be at your back while I go back to the bunker again. All the stupid stuff on YouTube will be in our comments. Oh. Ah, yes. Another day, another depreciating dollar.